question, we already know that the joint density function of fxy equals to b when x squared and y squared is less than 1 or equal to 1 and equals to 0 in otherwise. The first question is we should find the b to make the joint density function valid. In this case, we can simply see the equation x squared plus y squared is less than 1 or equal to 1. The area of this equation is simply pi. So in this case, b times pi equals to 1. b should be 1 divided by pi. Then we should know that the joint density function, we have already found the b. Then the second question, we have to find some expectations. In this case, we can simply apply the equation that ex equals to 1 divided by pi, the integral from -1 to 1, that is the x, and then the corresponding y, as can be shown from picture, should be lower bound should be minus square root of 1 minus x squared to the positive 1 minus x squared square root xy dx x times dx dy. Since we already know that x is an odd function and the integral lower bound and upper bound are symmetric, so the result of the integral should be simply 0. Then we have to figure out ex when assuming lowercase y. And this answer should be the integral from -infinity to infinity x times the density function of fx when assuming y happens dx. That is the integral from -infinity to infinity f(x) times the joint density function of fxy divided by the marginal function of fy times dx. And that should be in the combination of ex divided by fyy, then we have some integral. So the answer should be 0, 2, since the expectation of x is 0. So in this case, we have already know that for every y, the expectation of x when assuming y equals to 0. Then we have to figure out ey. Ey equals to 1 divided by pi, the integral from -1 to 1, integral from minus this to the positive 6, and y dx dy. As we have discussed before, this is an odd function and the integral is symmetric, so the answer should be 0, 2. And in this case, ey when assuming x happens should also be 0. And that can be applied to, for every x, the expectation of y when assuming x equals to 0. Now we have to figure out the expectation of x and y. Exy equals to 1 divided by pi, -1 to 1, minus this to positive this, xy dx dy. And in this case, we should also know that x times y is an odd function as well, and the integral lower bound and upper bound is symmetric as well. So the answer should be 0, 2. So in this case, we have already know that EXY actually equals to EX times EY and equals to 0. So in this case, we know that X and Y are uncorrelated. And that's the answer of the question 2. That's all. Thanks.